So welcome back students to the course of computer graphics and multimedia. So CA POL 208. So I am SENTHIL SELVAN. So I am presenting the computer graphics. So this session we are going to see about the broadcasting standards. So what are the broadcasting standards available worldwide? So the mostly used broadcasting standard is NTSC, PAL, SECAM, and currently we are using HDTV everywhere in the world. So NTSC, we'll see one by one this broadcasting standards. So first thing is NTSC. So NTSC stands for National Television Standard Committee, and so these standards define a method for encoding the information into electronic signals that creates these pictures on the televisions. So this NTSC is a television broadcast system used in number of countries. So like in which countries they are using it, I'll list out that. So Korea, Japan, so Canada, North America, so part of South America, so Mexico, and then the Caribbean islands. They are using this standard NTSC standards. So and it's named after the National Television Systems Committee, the industry-wide standardization body, so that created it. The National Television System Committee was set up in 1940s by the Federal Communications Commission. So in the United States to establish a nationwide standard for black and white TV transmission. It's specified as standard using 525 horizontal lines, so 30 frames per second, so two interlaced fields per frame, so also called as 2:1 interlacing, so which things you can identify in your televisions. So 262.5 lines field, 60 fields per second. So these are the some specifications they are following in NTSC. So 4:3 aspect ratio and the frequency modulation for audio signal is used here. In the 50s, NTSC standards framed in the 1950s 52, and one frame equal to 525 horizontal lines and per second, so 130, 30 frames they will produce it, and the two interlacing things I told it, and it's 60 hertz TV, and the interlacing is used to reduce the flickering televisions. And as per the recommendations of this committee, so this color information was added to black and white image by adding the color subcarrier to the video signals. So a subcarrier is a separate analog or digital signal carried on. So the main transmission signals which contain some extra information. So TV signals are transmitted with the luminance spot as the main signal and chrominance spot as the subcarrier. Due to certain technical considerations, the addition of the color subcarrier also required a slight reduction in the frame rate from 30 frames per second to 29 frames per second. So due to this, a discrepancy between the real time and the time stamped on the video was introduced, so leading to the concept of non-drop frame mode and the drop frame mode. So that one we'll see it later. So in the NTSC uses a chroma subsampling scheme of 4:2:2. So it has been mentioned that each frame in the NTSC video consists of 525 horizontal lines. However, only 480 of them are actively used for generating the pictures on the screen. The rest again is used for synchronization and vertical retracing. So in a color transmission, the luminance signal takes the place of original monochrome signals used for B or W TVs. The chrominance part of the signal is represented by two subcomponents known as the one I phase and Q quadrature. So the I and Q signals are amplitude modulated in quadrature onto the subcarrier wave. The I signal is in phase with the carrier wave and Q is in quadrature, that is 90 degree out of the phase with the subcarrier signals. So I physically the represents the orange cyan axis while Q physically represents the magenta, this green axis. So the hue part of the given point on the screen is defined by the phase of the subcarrier at that point. So since I and Q are clearly phase sensitive, some sort of phase reference must be supplied. So this reference is supplied after each the horizontal scan and included at the back portion of the horizontal synchronization pulse, so which is known as the color burst. So we have y is defined like this: y equal to 0.3 r plus 0.59 g and 0.11 b. Red, green b the ratio. Sin q can also be defined in terms of RGB, so which is yes mentioned here. And the video professionals and television engineers do not hold this NTC in high regard. This is because during signal propagation, the phase relationships associated with the color signals is liable to drift, resulting in incorrect U at receiver sets. Originality. So we are not getting here. This cannot be controlled automatically. So a manual hue control knob is included in NTSC television sets. So in addition, crosstalk between the two color signals resulting from poor separation during the decoding also leads to incorrect hues. So for this reason, NTSC is sometimes jokingly referred to as never the same color. So originally the image we are having, red color means here near to the red color, so orange or some other color shades only will get. So exact image or videos you won't get it in terms of colors. So next thing is PAL. So phase alternate line is a TV broadcasting standard, so used in European countries, Asian, African, Australian countries, they are using it. And this PAL was developed by Walter Buch in Germany, and it is first introduced in 1967. The French electronics manufacturer Thomson later bought Telefunken. So the PAL system uses 625 horizontal lines. Previously, 525 in NTSC, here 625 horizontal lines. Frame rate 25 frames per second. So there 30 frames per second. So interlacing is 2:1 with the 2 feeds per frame, and the aspect ratio is 4:3, and the chroma subsampling is 4:2, so which is similar to NTSC. Similar to NTSC, PAL also uses a color subcarrier signal with two amplitude modulated quadrature subcomponents. However, the color subcarrier signal is located at 4.43 megahertz instead of 3.5 megahertz in case of NTSC. The name phase alternating line describes a way that the phase part of the color information is reversed with each line, which automatically helps to correct the phase errors in the transmission of the signal by cancelling them out. So which is the problem in NTSC. However, the use of 625 lines as against 525 for NTSC leads to better quality picture in PAL. PAL is therefore sometimes referred to as perfect at last. Out of the 625 lines, only 576 lines are actively used here. So there in NTSC, out of 525, 480 which is used. Similarly here, few thing is used for horizontal synchronization and vertical retracing. So rest of that 576 lines are actually used to display the image on the screen. So the rest of things is used for synchronization and vertical retracing. To distinguish between this NTC and between this PAL. So PAL color subcomponents are referred to as UV, and which is defined according to the relationships like y equal to 0.3 r, 0.59 g, and 0.11 b. So which is already there in NTSC. But IQ and here UV, we are using that difference is there here between these combinations. So red, green, blue, yes, and the black and white combinations. Here some differences there. So next thing is SECAM, SECAM. So it stands for sequential color with memory. So it is invented by French scientists. So it's a TV broadcast standard used in France, Russia, and in Middle East countries. A team led by Henry D. France, working at the France D television company invented this SICAM standard. Like PAL, SICAM also uses 625 horizontal lines per frame and 25 frames per second. However, the fundamental the difference between the NTSC, PAL, and SECAM is that while the former transmits the two color signals simultaneously, the latter transmits only one color different signals at a time. It gets the information about the other color difference signal from the preceding line transmitted, which is stored in memory inside the receiving set. So because of this SECAM is free of color artifacts present in TSC and PAL. The color difference signals are denoted as dB, dr, and which is defined in a relationship like this. So dB equal to the combo of RGB, SD, dr, so the combo of RGB, which is given here. And another notable difference between the NTSC, PAL, SECAM is that while the former uses amplitude modulation to encode color information, SECAM uses frequency modulation to encode the chrominance information onto the subcarrier. The color difference signals are separately modulated onto two subcarriers having carrier frequency of 4.4 MHz and 4.25 MHz. So next thing is HDTV. So this is the recently used enhanced definition televisions or higher definition television standards, which is used worldwide nowadays almost in all the countries. So advanced television systems, ATSC committee or digital television DTV. So this digital standards provides TV stations with sufficient bandwidth to present 4 or 5 standard television signals or one high definition signals. These standards allow for transmission of data to computers and for new advanced interactive services. So these standards is used worldwide. So that is HDTV high definition television now available. So this high standards uses 1050 scan lines, and frame rate is also higher, 30 now to 60 frame rate, and aspect ratio is also higher, and the hertz frequency range they are using it, which is also higher here to generate better quality video. The number of bits per sample is chosen to be 8 for each Y, CB, and CR, which implies 256 quantization level for both luminance and chrominance here. So this high standard HTV also proposes using 2 chroma subsampling schemes, which is in the ratio of 4:2 and 4:0, and which is not possible in SCAM. And this HDTV video is a new standard for visual video for improving the picture quality compared to the standard NTSC and PAL. And so the resolutions also is higher here, 1440 cross 1152 pixels, 1080 visible space, and the ratio aspect ratio is 16:9 we are using nowadays. And wide range screen is 1920 cross 1152 pixels, and 3060 gigahertz frame rate they are using with 60 frames per second. And popularly in many films they use this standard. The past actually Star Wars episode, this movies and all, they used these standards actually. This standard nowadays they are using worldwide, and it's twice the resolution of interlaced format, which is then compressed for the transmission. This HDTV, and these are the aspect ratio they are using normally 4:3, and this is what they are using in it in HDTV. So HDTV is uh, so clear, the video was so clear, the resolution is so depth, more information was represented in this HDTV. So nowadays, worldwide, so everybody is using this. So this standard HDTV standards when they are using it. So, the ratio is 16:9, and the pixel rate is available in different ranges. So that's all about this broadcasting standard, students. So NTSC, PAL, SECAM, now we are having so HDTV across the globe. So thank you. Have a nice day.